Welcome to MongoDB session on Discover AI-driven innovation with Microsoft Fabric and MongoDB Atlas. My name is Diana Jenosh and I am a Senior Cloud Partner Solutions Architect at MongoDB. Living in the age of AI, it's kind of clear that enterprises have no choice but to adopt AI and Gen AI technologies at their core functions. The transition from analytics to batch AI to real-time AI to today's Gen AI is inevitable as customers demand more and more AI-enhanced experiences. To compete and win in the digital economy, you need to make your application smarter and surface insights faster. The results are twofold. Firstly, your apps drive competitive advantage by deepening customer engagement and satisfaction. Secondly, your apps unlock higher efficiency and profitability by making intelligent decisions faster on more accurate data. AI finds its applicability across industries. Looking at the two dimensions, AI-powered apps, this drives the customer-facing experience, while the faster and predictive insights drives a more efficient business process through fresh data and automation. We will look into a retail example in a demo in this session. Thanks to MongoDB Atlas key features, customers and developers are able to unify their operational workloads with AI data services. Starting with the document data model, it can store source data, context, chunks, and vectors side by side to the operational data. The inherent native vector search capability is tightly integrated into MongoDB Atlas. From cloud AI services to the latest generative AI frameworks like LangChain, LlamaIndex, and semantic kernel can be easily embedded with MongoDB data into apps. All this while being highly scalable and secure by default and providing a seamless developer experience across the AI lifecycle. Various components of MongoDB Atlas data platform work seamlessly as one integrated whole to enable AI workflow. From the strengths of relational systems like ACID transactions to manage triggers and functions, out-of-the-box search capabilities, data tiering, all on a global infrastructure and best-in-class scalability and availability. Microsoft Fabric is one-stop solution for unified analytics in the era of AI. Fabric brings data integration across data factory, data engineering, data science, real-time analytics, and business intelligence needs without compromising privacy and security of the data. All this using a single source of truth based on the lake-first data layer. MongoDB is a preferred operational data store for enterprises owing to its flexible document model and the features of the developer data platform which makes developers love MongoDB. It has many products that can enable operational analytics and application-driven intelligence like aggregation pipelines, analytic nodes, Atlas Vector Search, Atlas SQL, Atlas Data Federation, and charts, etc. Integration with Fabric enables enterprises to use the operational data in MongoDB in conjunction with the data stored in other data sources to build enterprise data warehouse, Spark, big data, batch AI ML, and BI analytics based intelligent applications. Currently, there are two mechanisms to bring the data from MongoDB Atlas to one lake. Data from MongoDB collections can be ETL'd into one lake in Fabric Workspace using the MongoDB source connector. Similarly, the data that is generated after applying AI ML and analytics can be persisted back into MongoDB Atlas collections using the sync connector. This beta connector announced here at Ignite is available in the data pipeline in Fabric Data Factory. This connector provides similar experience as the current MongoDB connector in ADF. The Atlas SQL-based MongoDB connector available in Power BI is now available in the Data Flow Gen 2 in Fabric Synapse Data Engineering and Data Factory views. It enables users to combine the data in OneLake with MongoDB data, apply transformations similar to Power Query, and persist the data in OneLake. Also, we have the exciting announcement of mounting being made available for MongoDB in calendar year 24, which will allow a one-click replication of data from MongoDB Atlas to OneLake. Once the operational data is landed in OneLake, it can be used by the Synapse data warehouse, data engineering, data science, real-time analytics to derive insights and intelligence. Now let's move to the demo on our AI-enriched e-commerce search. So why is search important for e-commerce? On-site searches are 1.8 times more effective. That is, people using search are likely to buy 1.8 times more than users that don't use search. But unfortunately, 50% of the searches yield inaccurate results. Low search and search not yielding results indirectly contributes to customer churn. So how do we improve the search experience? We can enhance it with vector search and AI to give improved search relevance, accuracy, and personalization, which in turn brings improved user experience. Let us now have a look at the high-level architecture of the demo. The pink dots elaborate the search flow. The user uses the on-site search to search for certain products with a buying intent. The user actions trigger a vector search which searches based on the meaning rather than the text search. The product title field is vectorized and stored in MongoDB alongside rest of the catalog data. We use Azure OpenAI's text embedding 𝗦𝗲𝗀𝗀𝗶 model to vectorize. The user query is also converted into vectors using the same model, and then a KNN similarity with Kozine algorithm is used to get the results based on the semantics of the query. The result is further sorted and ranked based on AI calculated fields such as price elasticity, product score to give the most relevant results at the top. The green dots represent the user activity flows such as views, cart additions, and purchase. All these activities are logged further and sent to MongoDB to persist them. The clickstream data along with the catalog data is brought to Lakehouse in batch to calculate the product score and price elasticity. The ATP and the discount price is updated to MongoDB back in real time whenever a purchase is made. All this while the catalog table in Lakehouse is updated. Power BI analysts see the latest report based on the purchases. Before getting into the demo, let's also look at the detailed technical architecture. We use MongoDB's Apache Kafka connector to stream the data from the product listing pages to MongoDB collections. We can combine the relevant attributes into a single view called the catalog collection. The catalog collection is then streamed into Fabric data science using the Spark connector. The Spark connector is also used to bring data from MongoDB in batch to Fabric Data Science to calculate the product score and the competitive pricing and update it back to MongoDB. The streaming notebook also writes to the Lakehouse, which is in turn used by Power BI to produce live reports. Now let us deep dive into the demo. So this is our AI-powered retail website called Fashion Hack. Let's first look at the search capability of this website. As you see, we have a checkbox here to show you the difference between the normal text search and the vector search. Obviously, you will not have this in your production websites, and you would use both the searches together in a hybrid manner for your advantage. So let's first look for some t-shirts with an image using the normal search. Oh, it's actually showing me sunglasses instead of t-shirts because of the fact that they have image in their name. So it's actually done a text search on image and has found these to be the most relevant results. Let's now give the same query to vector search and see the results. This is much better, and we are actually seeing t-shirts which have an image on it. Now we saw how vector search improved the relevance and accuracy of our search results. But we can enhance it further by adding intelligence to this search. And how we have done this in this website, as you can see, is the results out of the search are then sorted on the price elasticity and the product score. So price elasticity is a dimension that helps us understand how the product sale is impacted by the change in price. So as you see, we have lower price elasticity products shown up because these are the products that had a price change but that has not impacted much in their sales, and we want to show them upfront so that they are sold fast. And similarly, though not shown on the portal, we are also using product score to decide the sorting and ranking of the search results. So product score allows us to determine the sellability of the product, which is calculated using an empirical based method by capturing the number of views, the number of cart additions, and the final purchases that has happened to a product. So how are we calculating these and using it in our search? Firstly, what we are doing is we are capturing all the user actions like views, cart additions, and purchases in a collection in MongoDB. To do that, we are using the MongoDB Kafka sync connector to stream these events into MongoDB. So let's just add one of these products into our wish list and also add one of the products to our cart. And now when we check on our Kafka topic, we can see that both the products that we had added to the wish list is added with an event type view, and the one that we added to the cart was added with an event type cart. And these events are then sent to a MongoDB collection called clogs. So filtering on that one product ID, we can see it added into the MongoDB collection. Here is the entry that we saw on the Kafka topic. To calculate product score price elasticity and discount price, we are running Spark notebooks in Fabric's data science in micro batches. We use MongoDB Spark connector to bring the data from MongoDB, create materialized views out of it, and run the AI models on it. We are also leveraging the ML flow orchestration capabilities in data science to train a model, retail competitive price model Fabric 2 in our case, based on the random forest algorithm to basically predict the ideal price of the product. The model is trained on the fields like old sales and old average price, total sales and average price, and the min and max prices. We register the model so that it can be inferenced. And this is where we inference the model using the ML flow transformer, and then we calculate the predicted price by passing the old sales, total sales, average price, etc. We also calculate the price elasticity by using an expression which calculates the impact on the sales due to the change in the price. Using the predicted price, we come to know what is the discount that needs to be applied. Fabric provides this easy mechanism to see the different versions of the model, the experiment associated with it, and the different parameters that are associated with it, and also gives you an easy way to get the code that is needed to be applied even in a wizard form. Similarly, for the experiments also, you can see the different experiments that were run and what were the different parameters for each of the experiments. Now in the notebooks, we saw that we have used the MongoDB Spark connector in batch mode to bring the data from MongoDB and also update it back. However, there can be a requirement to bring the data from MongoDB and persist it in one lake so that it can be combined with the other sources of data, and a combined analytics can be run from them, and a Power BI dashboard can also be seen on the live data in the one lake. So, to bring the data from MongoDB into Fabric and persist it in one lake, we can use the existing MongoDB Power Query connector. You can use the MongoDB Power Query connector by using Dataflow Gen 2. This is the same Power Query interface you see in Power BI. You can go to Get Data, search for MongoDB Atlas, and you see the same MongoDB Atlas SQL connector. You can also use the blank query to retrieve the data from MongoDB. Once you have got the data, you can persist it into Lakehouse by defining the data destination. Similar to the MongoDB Power Query connector, you can use the MongoDB Data Factory beta connector, which is announced here at Ignite. The connector will provide similar experience as to what you have today with the connector in Data Factory, and this will be available from the data pipelines in the Data Factory view. To use the connector, add the copy data activity, select the MongoDB Atlas connector, give all the required inputs to connect to MongoDB. Once you have added the connection, test the connection to see if it is successful. And once you run the pipeline, you should see a success message in the pipeline. You can view the details of the pipeline as to how many rows were read from Atlas and moved to the Lakehouse. And finally, the data from MongoDB Atlas should have moved to your Lakehouse. Now we saw how we can use either the Dataflow Gen 2 Power Query connector for MongoDB or the Data Factory Data Pipeline Beta connector for MongoDB to persist the MongoDB collections data as delta Parquet tables in the Lakehouse. Once you have all the required tables added, you can create a new Power BI dataset and create a report like this. Now let us see how we can get the real-time updates into these tables and see the dashboard change in real time. For that purpose, we have created a data pipeline with one activity which contains a notebook and streams the data from MongoDB collection and updates it in Lakehouse. This is the notebook that is running in the pipeline. It is streaming the data from available to price status collection in MongoDB and adding it to the catalog final table by calculating the latest discounted price and the ATP value, and also persisting it into a delta Parquet table on Lakehouse. For the simplicity purpose, we have taken a subset of the data to show the real-time changes. As you can see, currently catalog min final 2 has just one record with a count of 2 and ATP 1. And that is also reflected in this graph on the Power BI report. Let us now go to our website and make a purchase and see if that gets updated in real time in our Lakehouse and thus in our Power BI report. I have added this product to the cart. I will increase the count and I will do a checkout and make the purchase. Now that the purchase is done, let us see if it was picked up in the Lakehouse and finally in the Power BI report. Refreshing the Lakehouse, we saw that it has added the new purchase. Refreshing the result, we can see that the new entry of shirts with a count of 8 has also been added. Thus, we saw how we can bring the data from MongoDB at once using the MongoDB Power Query connector or the Data Factory connector, and then apply real-time updates using a Spark streaming notebook, and thus getting visualizations on the Power BI report in real time. Thank you and hope you enjoyed the session.